welcome back. So this is the Extremely Open Science Stream 2 recap. So I'm really just recording. I just finished the stream, so I'm trying to just go over what we did. So today, first of all, I showed that as part of this project, one of the things I'm trying to do is dog food our own project. So dog fooding comes from this term, eating your own dog food, and it's one of the principles that we use to make sure that the stuff we're putting out for others to use really is good, is that we use it ourselves, because it's very, very easy when you're inside the project to forget and to not have that outside perspective. So in this case, and I also posted on the mailing list, one of the things I noticed last week is that we were missing some data that I expected to be there, because I have it on my laptop. So when I go to my directories, it's there. So I expected it to be there, but actually it seems that somehow we hadn't been actually made public. So I fixed that, and that was these. So this was actually in a different repository, which is the ArtCompare repository, where I now uploaded several new files. So I discussed a little bit what these are. So this is the GMGC v1, so the Global Microbial Gene Catalog version 1, and where we've annotated all of the unique genes and then use that to have an abundance estimate per sample. So given that, now we have multiple versions of the tools, and going back to the co-art project, so our co-occurrence project, co-arts project, we expanded this exploration script to first include all of the tools. I'm going to let's ignore this for now. So to include all of the tools that we had. So need a little bit of magic code here, and then ignore this. So I'm going to ignore a couple of things here. Alright. And then and now we have 9 tools, so we can do the same plot we had last week, where we just count. So for each, so here for each of these 9 tools, so we can see that, for example, this is what we had last week, deep ARG, now plotting using a log scale, where so there's a peak there of genes that are rare. And then in Leap ARG, we saw there was a relatively flat distribution. With the other tools, for example, RGI, we have a more typical long tail distribution. So there's a peak there. We can basically ignore the leftmost side, because that's the leftmost bar, because those are the genes that are not in our data set. And then it goes down more or less linearly in this log plot. Okay. Then, as I discussed, so this is using the full GMGC, which includes several different habitats. That was one of the advantages of the project, even, and so that can be a confounding factor for this type of analysis, and we decided to, okay, let's for now do the simplest thing, which is to just look at one of the habitats, and we're going to look just at the human gut, because the human gut is the one with the largest number of samples. And so we here spent a little bit of time again fighting with polars, or not fighting with polars, but trying to understand how polars work, but a little bit of Googling, and figured out that this is how we select. Based on these columns, we selected both the habitat for the human gut and the minimum number of inserts. So after quality control. So this is high quality inserts, at least 2 million. So we also had to go and get this metadata file, and I show that frankly, if you are really just interested in this one file, I really just advise you to go to the website gmgc.embl.de, click on downloads, and you will find it here. The per sample metadata. On the other hand, I'm showing how I would do things, and because also I'm very used to this, I got this through using Git Annex. Anyway, once you've downloaded the file, here using polars to load it, and now here we now use it to filter, and now actually I didn't show this on the stream, but we can see here the two versions side by side. So you can see, so here on the left, this is using all of the data, on the right using only the human gut samples. So, and as you can see, actually it looks quite similar in shape, the curves. You can see that the number of samples now goes up to 7,000, whereas before it went up to 13,000. So you can see that but the rough shape of it is quite similar. So this is where we stopped. I updated also everything on Git for the co-args project, and I will be offline updating the ArgCompare project because we also found a couple of issues there. So there was a little bit of chaos monkey going between different projects that interact, because as part of doing co-args, noticed that there was some minor inconsistencies in the ArgCompare project, so went back and forth to fix those. So next week we'll be continuing along these lines. Maybe we'll start exploring. We'll finally start exploring what these genes are, and trying to start to make sense of all of that. So with that, I will be posting everything online as usual. I'll post so the code is on GitHub. I'll post an update on the mailing list. I'll set up a stream already for next week, and I hope to see you soon.